Greetings scientists, I'm Haley from the Discovery Center of Idaho, and welcome back to Virtual Dino Camp. Your learning objective today is you will be able to understand the impact of meteors on the Earth's surface at the time of the dinosaurs. This week's lesson is from the day where we focused on extinction. This is an important topic because all that we understand about prehistory and prehistoric creatures stems from this extinction event. Today's activity is called Meteor Drop, and if you'd like to participate, these are the things that you'll need. Either grab a ruler or a meter stick would work too. You'll need like a plastic bin, any size is okay, it just kind of depends what you have. I prefer a little bit smaller because then you don't have to fill it with as much flour, which is something else you'll need. If you can tell, I don't have an exact measurement here. I put about 2 inches worth of flour. I bet you if I were to guesstimate how much I put in, I'd say about 5 cups of flour. And this can be wheat or white, doesn't matter. And then I have various balls, and I recommend round shaped to simulate a meteor, but I also found something that's heavier so we can see the impact of weight distribution. But I've got a golf ball, I've got a bouncy ball that looks like the Earth, so how funny. And then I have a balance weight, and this is about 1,000 grams. That's all you need. To set this up, you're going to put your flour in your bin and you're going to kind of flatten it out. I also like to make it a little more realistic to Earth's surface so it's a little bumpy. And then you are going to make sure you have your ruler, you got your stuff. Now these balls are going to simulate the meteor drop. I do it about 2 feet above the bin. If anyone wants to remind me how many inches are in a foot, I go ahead and stick my finger, boom. This is about 2 feet, 2 ruler lengths. And I'm going to drop this in the flour and we're going to measure the impact both by its depth and its diameter. I'm going to simulate the meteor drop extinction of the dinosaurs here. So go ahead and watch the flour closely. And I want you to try to hypothesize what you think this shape and size of ball, again, it's a bouncy ball, so it bounces, right? What kind of impact that's going to make. All right. Okay, I'm going to carefully remove this ball, and you can see its imprint, all right? It's really small. This doesn't have a lot of weight, so I didn't expect much. I'm going to go ahead and measure in centimeters, actually, because this isn't very deep, so that inches is kind of hard for me personally, but you can do either. So I'm going to kind of stick the end in here to get the full crater, and I will use sometimes like a piece of paper. Watch me use this to kind of make sure I know where the top of the crater is, and I'll follow to the ruler. So I want to say that's about 1.5 centimeters deep. Okay, and then that's the depth. The diameter, let's try to, it's hard because this doesn't flat. I'm going to try to flatten this. So I'm going to go with about 5 centimeters wide. Okay, a tip on using a ruler, if either you don't have one or maybe you only have one with one of the other sizes, inches or centimeters, you can take a string and you can measure it out inch by inch. And if this helps you, an inch is about my index tip of my finger. So even if you don't have a ruler, this is a super accessible activity for you. So when I say the tip, that little bit of your finger, and if you do that 12 times, cut that string, this can be used as a ruler and you can use it to measure the depth and diameter. When you're doing these meteor drops, it's really important as scientists to write down your data and collect. So we're doing 3 different types of meteors. So I went ahead and recorded what we just discovered. So it's 1.5 centimeters times 5 centimeters, and that's the depth times diameter. So that's the order that I write this. Again, I'll remind you, scientists always take tons of data so they can make sure to either prove their hypothesis or push it further and study another avenue or perspective. So it's really important to write your stuff down. It's time for the second meteor drop, and we're using this golf ball, and everybody kind of knows how heavy a golf ball is. You can probably chuck it pretty hard. It doesn't bounce though, so it's something to think about with weight distribution and impact. All right, here we go. Okay, I'm gonna go ahead and remove that. That one's a little bit deeper than the last one. That's a little interesting to me. So it's a little bit heavier of an impact. I'm gonna go ahead and put this ruler in. Okay, and then I'm probably gonna guess my finger. Again, scientists are more accurate than I am being right now, but this is for the fun of exploration. This is 2 centimeters depth, and then diameter-wise, I'm gonna say about 4.5 centimeters. Make sure to record that data we just collected. So I measured 2 centimeters for the depth and 4.5 centimeters for the diameter. And that's a pretty close, just a little bit heavier. The reason I say heavier is because it's a little bit deeper than the bouncy ball, and it's a little bit, well, it's shorter in diameter, which means it went deeper, really, if you were to think about the difference here. And for our last meteor drop of the day, this one might go in my face, so we'll see what happens to the flower. Let's test it out, all right? Oh, that was a good one. I bet that would have killed the dinosaurs for sure. All right, let's go ahead and measure this. I'm gonna stick this in here. All right, oops, I messed up that a little. I'm gonna go with 1.75 for depth, and diameter 4 centimeters. Make sure to record this last data piece. So we measured 1.75 centimeters in depth and 4 centimeters in diameter. Now, what's interesting is that was the heaviest of my 3 objects, my 3 meteors, but it's not as deep. I really did expect it, but this is something to consider. These are round, and this is a flat. It's round on the bottom, but it's 3-dimensional more than this is. So this is going to skew your data. They're not the same shape. Even these two are similar shapes. This is not. So it's good to really pay attention to what kind of controls that you pick and make sure not to have too many variables, especially when you're measuring for the same consistent data. It's important to pay attention to what kind of objects that you choose for your meteors, because if you notice, this is round as well as the golf ball. So these are control. This is a variable because it's not the same shape. So while we thought this was going to be heavier, it's heavier than these two. I think the shape really disrupted its impact. What's going on here when it comes to the science? The meteor that killed the dinosaurs, it happened 66 million years ago. It fell in the Yucatan Peninsula in Mexico, and there's still a crater there today from the impact. You'll have to go look at the picture. Now, this disrupted flower, what this represents, and what we were measuring was the ejecta, which is particles ejected from an area of impact. So that could be a meteor, it could be a solar explosion, or it could be a volcanic explosion. So somewhere where there's a lot of pressure built up or a lot of impact. There was also ejecta released into the air. The dirt particles went up, which changed the atmosphere, making it inhabitable for the dinosaurs. Now, my challenge to you is to simulate another part of the extinction. And when the meteors hit and impacted, they also disrupted the volcanic slumber, which caused some volcanic eruptions. So I would like you to simulate your own volcano. Now, all you need is a water bottle. I have these little miniature ones, which are nice because it's not as big of a mess, but I also know the reality that everyone loves making big messes sometimes. So you could also get like a regular water bottle or even like a 2-liter water bottle. Go crazy. You will need some baking soda, doesn't matter the brand, and some vinegar. All you gotta do is, you'll set this on a surface. This is my messy surface, so I would set it somewhere where you can make a mess where mom and dad doesn't get mad. And you are going to pour a half cup of vinegar into this bottle. I'm not going to do it right now because I'm not ready for the mess quite yet, so I want to make sure that you share them with me on social. So you got half a cup of vinegar in the bottle, and then for the baking soda, you are going to take a tablespoon, and you will, when you're ready for the volcanic explosion, so make sure you step back as soon as you put the baking soda in. You're going to pour it into the water bottle, and then you're going to step back and let the chemical reaction happen, and boom, you've got yourself a volcano in your kitchen. Thank you so much for joining us for Virtual Dino Camp. Make sure to tag us on social and your curiosity and creations and your volcanic explosions. And we look forward to seeing you here at the Discovery Center soon on July 7th for King Tut, Treasures of the Tomb. See ya.